Hello students. So in the previous lecture we had discussed about continuous charge distribution, and I think we had solved two questions based on continuous charge distribution. And yes, of course, one thing was sure that in order to solve the questions based on continuous charge distribution, we need to take help of integration, right? And yes, I had given you the question that what if linear charge density varies as lambda equals to lambda 0 cos square theta, right? See, already the question was being discussed in the previous video that there is a ring of say any radius a, and the charge density was changing according to the equation lambda 0 cos theta, right? And we had solved the question which was lambda 0 cos theta. But now what if the charge density changes according to this equation lambda equals to lambda 0 cos square theta, right? There is a ring of radius a, the linear charge density on the ring changes according to this equation lambda equals to lambda 0 cos square theta. Now you have been said to find the total charge on the ring, find the total charge on the ring. Okay, see, suppose charges are being distributed on the circumference of the ring like this. Fine. First we will calculate dq, right? Let this charge be dq. Suppose it subtends an angle d theta. A is the radius. Okay, and this is known as arc. This portion, say A to B, this will be arc. Clear? Okay. So now what is lambda equals to? Q by L, its linear charge density. So it will be charge per unit length, or lambda is also equals to dq by dl. Lambda is equals to dq by dl. So now dq will be lambda into dl. What does this dl represents? This length of arc. So now dq is equals to, I am going a bit faster because the same procedure we had followed in the previous video, previous sum, right? So dq is equals to lambda 0 cos square theta, dl is length of arc, and length of arc is equals to angle into radius. So this part subtends an angle d theta, so it is angle into radius. Clear? So finally dq is equals to lambda 0 a cos square theta d theta. This is the charge dq, which is on the length dl. So total charge q will be obtained by integration. Let's integrate this dq. So total charge q will be equals to integration. You can either go write close integration or 0 to 2 pi. Lambda 0 a cos square theta d theta. Clear? Lambda 0 a can be taken constant, so it will be outside the sign. Fine. Cos square theta can be written as 1 plus cos 2 theta by 2, right? There is a formula in maths. Cos square theta is 1 plus cos 2 theta by 2. Fine. Now let's separate it out. So this will be lambda 0 a bracket 0 2 pi 1 by 2 d theta plus 2 pi cos 2 theta by 2 d theta. Clear? Okay. So now this will be lambda 0 a bracket, half again can be taken outside the sign. Half can be taken outside the sign. Integration of d theta will be theta. So this will be 1 half theta 0 2 pi 1 half. What is integration of cos 2 theta? Sin 2 theta by 2. So this will be sin 2 theta by 2. Apply the limits. Okay. Clear? Fine. Now let us place the limit. Lambda 0 a bracket 2 pi minus 0, upper limit minus lower limit. So 2 pi minus 0, 2 pi by 2 plus 1 upon 4 sine, instead of theta we will place 2 pi. So this will be sine 2 into 2 pi. So that is sine 4 pi. That is sine 4 pi. Sine 4 pi is 0. Minus again apply 0. Sine 0 is 0. See, instead of theta place 2 pi. So it will be sine 2 into 2 pi. Sine 4 pi. Sine 4 pi is 0. Minus sine 2 into 0. So that is also sine 0, which is 0. So this term will be 0. So final answer will be pi lambda 0 a. This is the total charge on the circumference of the ring. Clear? Clear? Fine. We'll discuss one more rather speaking sum. I would rather say that it is a special case for an arc. How to calculate the electric field for an arc on which continuously charges are being distributed, right? So in the next video we'll discuss that special case and we'll derive the formula for arc, electric field because of arc, and on arc charges will be continuously distributed. That means there is an arc on which charges are being continuously distributed, and because of these charges we want to calculate the electric field at the origin. Clear? So that will be a general result, and from that particular result we can solve different questions. Clear? So in the next video we will discuss that question.